This course actually we have two parts. Okay, so we would have chapter 1 to chapter 9 that we call it AP Computer Science A. Okay, and then we have chapter 10 to chapter 17. We call it B. So totally is a 17 chapter course, and it is going to be deeper, much deeper compared to pre-AP Java. Okay, and you will cover more things. But since you guys have already started something, so some of the ED topic I may skip, okay? So let's get started. So now we are on chapter 1, introduction, okay? So introduction, we are going to go over the computer hardware, software, and this portion, probably most of you should know about it, so I am not going to spend too much time on this, okay? And the second part, we will talk about the Java and other programming language, okay? And we will try more advanced projects, okay? And then compiler versus interpreter, okay? 3 go, okay? Okay, we have 4. Actually, we have also know about Java knowledge, okay? Let's get started with what is computer. So for this one, basic definition I'll skip, okay? Now, first one, the first generation computer, okay? We talk about this company IBM, okay? IBM stands for International Business Machinery, okay? So around the year of 1950 something, UPenn has the Univac, okay? That's the first computer, okay? After that, actually, her first electronic computer. After that, we have been seeing a lot of computer being built. And 1960s, we start to have seen such some computer being in use, okay? So at that time, the example company is this one, IBM, okay? So Nathan, tell me, in this picture, right, there's a gentleman, there's a lady. Which part is computer?
Like everything around, like those big boxes.
Everything around?
Yeah, I think so. Because I remember like the computers back then used to be really big and they'd take up a whole room.
The entire room is the computer, I think.
Entire room is a computer, yes. So this one is your CPU, right? This one is your input unit, right? This lady is handling the tape driver, so this one is your secondary storage for the tape, right? Is that okay?
Okay.
Yeah.
So the whole thing is one computer, and the power of this computer may be less than today's personal computer. Okay? And here I picked IBM because it's actually business machinery. At that time, it actually is, people are thinking about computer is for business machinery. So basically, it is used to process students' score report, process some insurance record, you know what I'm saying? Process some bank application, basically used for business. So international business machinery, that's the name of IBM. Is that okay? That's stage 1, okay? And then since 1970, there's a change, okay? 1970, July 1st, January 1st, 1970, okay? 1969, we have 3 things happen. C language, Unix, okay, and PDP-A, okay? PDP is a computer name, and later become PTT-11. These 3 things invented at the same time. Unix is written by C language, is installed on the PTP-11, okay? And Unix stands for Uni is 1, right? So Uni operation system. So it's designed for one computer, single box use. You know what I'm saying? So since that time, computer merged into one box. Is that okay?
Okay. So I just want to recap what happened so far. 1950s computers are invented. 1960s IBM, large-scale computers, international business
Machinery, yes.
machinery, yes.
Mm-hmm.
And then later, 1969, near the 70s,
Mm-hmm.
there was Unix, C,
And
what was
PDP 11, yeah.
Can you write it down?
PDP 11.
Thank you.
So here, let's see. They are PDP 7, PDP 8. Okay, it's from digital. Okay, there is a machine called PDP 8, and later become PDP 11. So PDP 8 is 1965. Okay, so it's something like this, and then later they pull the system, the Unix system, into PDP 11. So that's supposed to be the first Unix computer being put into here. It's done by digital. And digital later being acquired by Compaq, Compaq acquired by HP. You know what I'm saying?
All right, I get it.
Is that okay? And right here, the design of PDP-11 inspired the design of late 1970 microprocessor, including Intel, whatever. You know what I'm saying? You see here?
Yeah.
So what happened is like Unix PDP-11, that's a hardware, right? This is hardware. This one's OS, and C is the language, right? So C go to C++, go to Java, right? Unix go to this CPM, go to DOS, go to Windows, right? And then the other route is this Unix also being ported to Mac OS. Mac OS is also Unix based. There's also Linux being spun from here, okay? PDP-11 go to development of the personal computer. Is that okay?
Okay.
So we use the time 1970 as the starting time of the computer. I think I talked about this already, right? So let's do this one. First, let's look at the computer time. Okay, chapter 1. First, let's look at computer time, okay? Okay, computer time. We want to grab the computer time from the computer, okay?
Okay.
So here is one project, will be the homework for today. Is that okay? I'll try to challenge you guys, see if you can develop by yourself. I'm going to do the easy part, and you will do the difficult part, okay? So now the first thing is like I get a long time stamp. This one probably I teach you already, okay? So you'll be system.current time minutes, okay? And this thing will give you a long integer. So that's actually, let me see, current time minutes. I'm missing an I here, okay? So I will send you this one for you, but you will need to develop some program, okay? So here I actually can do system.out.print line, okay? And here I will do timestamp, okay? So I do timestamp, and then I actually do this. So here is a long integer given, okay? And what this long integer given is actually is the number of minutes, seconds since 12 a.m. Okay, what day is 01/01/1970? Okay.
Okay.
This timestamp will be the minutes this time, but it actually is in what? Greenwich time, the British time. Is that okay? It's
Okay.
Greenwich time in British time. Okay. So now let me actually import something here. I import java.len.thread. Okay, java.len.thread. What am I doing here is actually I'll do while true. Do this thing. Okay, do this thing. I print out the timestamp, right? And then after I print out the timestamp, my thread.sleep 1000. 1000 means 1000 milliseconds. Okay, so it actually is 1 second. Is that okay? So print timestamp 1 second, print timestamp 1 second. Okay, let's go. Here 1000. Okay, it need to have the exception. So let me just source exception. Is that okay? So
Okay.
nothing special. Just do this one. Okay, let's see. It didn't update. Let me see.
It's because you assigned that one timestamp to a variable, and it just uses that same one every time.
Yeah. I know. Sorry. So actually, this guy should be cut and put it here. Okay. I make a mistake. Okay, I fix the number. I make a mistake. I fix the number. Is that okay? Every time we should grab it. Okay, I'm sorry. So let's get started again. Here we have this one. Yeah, is that okay?
Okay.
It's not exactly 1000, but actually around 1000. Is that okay? It can be exact, okay? It can be exact. But anyway, that's actually slipping about, because there's an I/O delay time, so roughly it's the same. So this one actually every 1 second we will do that, okay? So now actually this one, we got a long timestamp and we actually print it out, okay? So before we print out this thing, let's do one thing, system.out.print. Let's actually move this guy also into here, okay? Move this guy. So this time actually is based on the computer zero time, right? Computer zero time is actually this one, ticking, okay? And actually is about 1001, sometimes 1001, sometimes 1000, okay? So it's changing on each digit, right? Okay. The key point is that it actually is every second you will do it, okay? Every second you will do it. Now we got this one ticking every second, okay? So this time we call it Unix timestamp, okay? So it called epoch converter, okay? So it's actually epoch time. It's a epoch Unix time, okay? Epoch Unix time. So here is a second since this time. It's using the Greenwich time, okay? So you reload, okay? So that actually apparently is what? Similar to our timestamp, right? Let me see. Let me bring up my timestamp. It's actually similar to our timestamp, right? It actually is close, right? It said that we have more digit because we are using millisecond. It's using digit, right? It's using a second, right? So that's called Unix timestamp. So all computer based on that time, okay? Whatever time is based on that time. So now we are going to convert it to today's hour, second, and the minute. Is that okay? So starting from here, actually, we will convert it to a integer. Okay, total seconds. Total seconds will be equals this whole thing, the time stamps divided by 1,000. Is that okay? It's in milliseconds or divided by 1,000. That would be correct, right? That would be total seconds since 1970, January 1st, right? Minus what? 7 hours. 7 hours is the time zone difference between Pacific time and actually Pacific time and the Greenwich time. So for lesson, you probably use 5, okay? So 7 hours, each hour is 3,600 seconds. Is that okay?
Okay.
Is that okay? So this one I convert it to integer and then minus that one. So that's the total number of seconds. And this one here, I no longer need this. Okay, this one here is the total seconds since 0101, actually 1970. And it's actually Greenwich time, so UTC. No, this is Pacific Daylight Time, okay? Because I minus 7,000, okay? 7 hour, okay? Now I have the total second, so now the next one I'm going to do current hour. Current hour would be the seconds divided by this. I'm sorry. Here, actually, the first thing is actually, let me see, number of days. Number of days will be the total second divided by this. These are days passed. Is that okay? Since that day, how many days have passed? Is that okay? And then we have seconds. Seconds will be so this one will be seconds since 12 a.m. this morning. Is that okay? Total seconds since this morning. Is that okay? So now next one will be integer hour. Okay, integer hour will be total second divided by 3,600. So this one is hours passed since 12 a.m. Is that okay? And then here we have seconds equals seconds multiplied by 3,600. That would be seconds since this the start of this hour. Is that okay?
Okay.
Next one, we have integer minutes equals seconds divided by 60. That would be seconds since, minutes since the start of this hour. Okay? And then we will have seconds equals seconds divided 10 multiplied by 60. Okay, and that will be seconds since this hour. Okay, and then we would have a string AM PM will be equals conditional if the hour greater equals 12. Okay, question mark, it will be PM, right? Otherwise, it will be AM. Is Is that okay? If more than 12 hours passed, then it should be PM right now, right? Otherwise, it would be AM. So this one timestamp here should be question mark, conditional statement. Okay, so right here, I'm going to print F now, not print. So it would be actually like this, okay? Percentage 0 to D, okay? Column, percentage 0 to D, okay? Percentage, and then percentage 0 to D, okay? Backslash F, okay? Comma, hour, minutes, seconds. Is that okay?
Okay.
And then over here, at the end here, I put a string. Okay, and this string, let me put in AM, PM over here. AM, PM can be AM, can be PM. So let's see. Is that right? 335, right? Is that okay?
Okay.
So here actually this one actually is after we decide actually after we actually calculate the AM PM, we can also adjust the hour.
Okay.
Yeah. Okay.
Yeah, 335.
So what's this? What am I doing right here?
Okay.
I design a clock.
Yeah, you made a clock.
I made a clock and grab it from my system time. Is that okay?
Okay.
Okay, now your project, right? This week, your project for this week is, okay, I have the number of the day over here. And I already print out the hour, minutes, and seconds over here. Can you come out with a project to do what? Give me the year, months, and date.
Okay.
Before it is okay. I'll give you the total number of day over here already. Is that okay?
Okay.
So you do the difficult part. Okay, easy part I finished already. So still calculating the computer time. So let me actually post over here. Okay, you can actually download this one. Is that a good project or no?
It's a pretty good one.
Interesting, right? But it's also quite challenging. So don't get frustrated, okay? You try your best. So I give you this computer time, okay? This course, I try to make it a project based, okay? So will be more challenging. So project 1, computer system time, due next week. Is that okay?
Okay.
That's the #1 project you will get, computer time. So here I already teach you how to get the hour, minute, and second. Okay. So this total second will not change. It's the same. So you probably need to do something between here. I'm sorry, between here after the day being decided. You know how many days left, right? So you need to know what year it is right now based on this day. What month this one is based on this day. What day it is based on this day. Is that okay?
Okay.
So if, say, my hint is this, if 0 day pass, that day would be 01/01/1970. Okay. If 1 day pass, it will be 01/02/1970. Is that okay? If 3 day pass, it should be 01/04, right? Is that okay? 1970. Is that okay?
Okay.
So day 0 is this day, and you need to figure out what is the 06/07/2020 is. Is that okay? Or given any day. You need to be able to figure out what day it is. Is that okay?
Okay.
Based on the number of days passed. Okay? It's a good project. Please work on it. Okay? Okay, so here actually I explained to you what is computer time, and we found a interesting project. So this Unix example will also be given to you. Okay. Now will be also be given to you, and that actually is first generation computer. Okay. Then in early 1980, we enter into personal computer, right? So at that time, before that, actually is a mainframe computer, and IBM 1401 is the machine that we shoot the Apollo 11 to landing on the moon, 1969, right? So actually, it's using the IBM machine to shoot to the moon. Okay. Calculate the orbital information. And actually, after that, early 1980, we had personal computer. So in my college day, we have the first generation personal computer. We don't have color monitor. So everything is single color. We call it monochrome computer, and there's no graphics. So everything is text mode, monochrome graphic. Monochrome text mode, okay? So when I was in college, the computer we see is called monochrome text monitor. It's something like this, okay? The computer we see is something like this, okay? That's the kind of computer we see, and we try to draw graphic to play game. Okay, that's when I was in college. It's something like that. Okay, and when we first see the color windows, I'm almost out of college. Okay, is that okay?
Okay.
We have been playing those games for a while, and I use this company Dell because Dell is the most powerful company in the 1990s. Okay, it's the build to order computer. You can actually tell Dell what to put into your computer unit. Okay, you want to upgrade CPU, upgrade monitor, upgrade whatever, that's up to you. So at that time, everybody build their own computer. Okay, there's a period of time until around maybe 2000 something. People start to do that. Okay, so now the third stage is this one, mobile computing. So mobile computing, I picked this company, Apple. Okay, so Apple's Macintosh computer was actually competing with Windows for a while, but it almost lose all the market. So at the lowest point, Apple dropped to 3% market share. It's struggling between 3 and 5% for quite a while. Right now, I believe maybe 10 to 20%. Okay. But personal computer will still be bigger. But, well, personal computer market or desktop market, Apple is not doing that great, right? But around 2000, 2003, they start with the first product called iPod. Okay, iPod. So MP3 music come up. So it's a personal mobile computing get started. Okay, first one is this one called iPod. Digital camera get started around that time as well. PDA, okay, personal digital assistance.
So this is one in the early 2000s, right?
Until recently. So this one started, iPod is somewhere there. This digital camera maybe 1997 something started with this. Okay, flip phone and then PDA, right? And later we start to have the so-called iPod, right? And cell phone, iPhone, right? iPhone before iPod.
Right.
So this one probably ruling around 2003 to maybe 2013, 14. Okay, Apple is the best company in this era. We call mobile computing. So computer is actually can be moving around, no longer a desktop computer, not just a notebook. Is that okay? Is that okay? So this era is actually mobile computing. So we have, before that we have what? business use computing, then personal computing, now mobile computing. And the next stage that we are in right now is this one. We enter into an era. We enter into an era called this one called the age of bots. Okay, we are in the age of bots. So here you go to here, you say the age of bots. Oh no, I misspelled it wrong. Okay. Yeah. So we are now in the age of bots. Okay, all kind of bots around us, right? So if I don't use the age of, I just say bots. Bots means all kind of bots, right? Robots, right? So what does this bots really mean? B-O-T. This all kind of bots.
Bot is basically a machine run by a computer that does a certain task.
What's the difference between computer and bots?
A computer is used by a human to calculate things. A bot is supposed to do things autonomously without human support.
Yeah. Okay, the keyword come. Autonomously, right? Is that okay? So auto and also responsive. So basically, you talk to him, you chat to him, you take some movement, he will react. Is that okay?
Okay.
So it's a responsive computing. It's no longer I give you command. Okay, mobile computing, personal computing, or business computing, it's always me as a programmer or person give order to my machine, and it just run, right? Now, no longer that. Now, actually, you get something, he responds. You get something, he responds. So actually, it's responsive. It actually is responsive. It's autonomous as well. Those are called bots, right? It comes from robots, robots, right? Moving bots, Autobots, right? Coming from these words. Is that okay? Is that okay? So if you go to here, actually it's called chatbots, okay? Google chatbots. Searching internet for Google chatbots, okay? Google chatbots, we see Google chatbots. No S, let me see, Google chatbots. It actually has a lot of chatbots. Let me see. 10 most innovative chatbots, okay? So there are a lot of different chatbots. Let me pick one, okay? Let me don't search this. Actually, it won't end up with a good one. So let me try something that I know, okay? So chatbots. Let's try this one, Chomsky chatbot, okay? Chomsky, the world's best, okay? Chomsky chatbots, okay? So actually, Chomsky chatbot. Yeah, you see, I say, how are you? He said that I'm fine, thank you, okay. Yeah, is that okay?
Yeah.
Okay, whatever. He tried to respond, right?
Right.
Okay, so this is a Chomsky. You can pair around it, okay? Let's go chip. So now it's become a responsive computing. Okay, it actually is responsive computing. So this actually is responsive computing. So that's the fourth era. And why I pick Amazon. This era, why I pick Amazon and I did not pick Google or pick anyone else. Because Amazon is leading in this one, Amazon Web Service. And who is this guy? Echo, right?
Yeah.
And Echo connected with the Amazon shopping, right? Right? And this one actually all kind of service. You can get map service, you can get the music, video, if you know how to chat with your Echo, right? Is okay? So it's a representing company for responsive computing. And also Amazon is the most highest market capital company, right? Number one, most expensive company, right? Is okay? So nowadays this guy is leading, okay? This guy is leading. Number one, okay? Since 2015 and now. Okay, it become more popular with after 17, okay? Is that okay? So this different era of the computing we have been experiencing, and we know we are moving forward beyond this point, okay? We are moving forward beyond this point. And this computer board, I think I explained it before in the pre-AP course, so we just see this one. It's a CPU, memory, and I/O, okay? I don't want to spend too much time over here. Okay, this is a chart I think we are okay. So one important thing AP may test is what is operation system, okay? And Choi, what is operation system?
An operating system is basically a system computer that manages everything about it.
Yeah, so all of the resource in the computer being managed by the operation system. So it's a piece of software, okay? So typical OS we are talking about is Windows 10, it's Mac OS 12, okay? It actually is the Linux, Red Hat Linux. Is that okay? These are operation system. So now this is okay. We don't waste time to discuss this, okay? One thing is important is, okay, maybe important. So computer science is the science to study computer. Computer engineering is actually the engineering job to actually build a computer, okay? Software engineering is the engineering job to create software, build software, okay? Data science includes three things: math, computer science, and domain knowledge. You use mathematical tool to model your domain knowledge. Say if you are a bioinformatics expertise, you need to actually model the computation of the fingerprint, right? Fingerprint. So everybody has some sort of fingerprint, right? Is that okay? So that's called domain knowledge, right? Mathematical model means this one I need to match with tons of different fingerprint and find out the best match, right? Find out the best match. And then computer science is the tool to facilitate all the math and the domain knowledge, okay? So all these things integrated together become the data science. So data science is a multidiscipline field. So we build up the fingerprint so we can use it for computer security control, right? Like iPhone has the fingerprint. Now iPhone start to use what? Use your ID photo, right?
Using facial recognition, yeah.
Yeah, it's for ID photo, right? Is that okay?
Okay.
So that's something we have here, okay? Any questions so far?
No.
Okay, then we can apply the data science to social media, marketing, travel, healthcare, right? Uber, right? Lyft, sales, credit, insurance, automation. Is that okay? All kind of different field for the data science. Okay. So that actually is today's development for computer science and what you may seek for in the college as your major. Okay. So now we go back to the Java. Okay, we have tons of different languages. Okay, we have tons of different languages: Python, C#, Scala, PHP, C++, JavaScript. Okay, SQL. Why we pick Java as our language for study, and why we don't pick Python? Okay, this actually is a very good argument. Some people actually argue why we don't pick other language. Another teacher actually push for Python for it. Okay, push for Python as the language for AP Computer Science.
I think it's just because of the nature of the programs.
Mm-hmm.
I think Java. I don't remember which coding it was, but I think. Excuse my parents, they're playing some music in the background, but I think Python is more math-based and Java is not, and I think that people naturally gravitated towards the the non-Python stuff, because they just felt, I think Python is just easier for more people to get, because it's easier to read, it's clearer to understand in terms of a logical sense.
Mm-hmm.
And even if Python is more compact, when you try to do very large projects, it becomes very unreadable and requires a lot on sort of mathematical concepts. I think Java is chosen because it was designed to be, simple. It was designed to be used by a lot of people in the first place, especially for companies and all that.
Yeah, your perception, I would say 95% is correct. Okay, 95% is correct. Number one, Python is actually easier, right? As a syntax, Python is easier. Okay, but performance is down. Java performance is better. Okay, but the syntax is a little bit harder. Okay, Python is pretty much open source. Java actually is proprietary. So it's owned by Oracle. And actually, Python is better organized. So we use Java because it actually is the best language to use to learn object-oriented programming. Okay, Python's OOP is very loose, so very hard to learn. When you get started, it's easy. Okay, first 3 months is very easy. Once you touch to the difficult part, Python becomes very bizarre, very unclear. Okay, even though it's still very robust, but it's very hard to learn. So we pick Java language because of its clearness in its syntax. Is that okay?
Okay.
Because more clear with that. And we need a language to learn basic language. So both languages are good. Okay, both languages are good language. They are popular for some. So that actually no problem. Okay, so here we look at this one, this book. Okay, the textbook I talk about. Okay, you should come here to download it. Okay, so here this one is our textbook, and chapter 1 to chapter 7 starting to input. Introduction to array before designing class. Okay, this portion is our Java 1. Java 1. Java 1, I also call it Java Programming Essentials. Most essential part for programming. And here it says fundamentals. Is that okay?
Okay.
So this light orange color actually is Java 1. Dark orange color, 8, 9, 10, 11, 12, we call it Java 2, okay? In AP Computer Science, it should also include recursion and sorting, okay? So AP Computer Science up to here, okay? But no interface, no I/O exception right now, okay? Is that okay? So actually, AP Computer Science up to here, Java 1 and Java 2, but no the cross-out portion. Is that okay?
Okay.
And for the user code competition student, I put Java 3 over here. That's the one I'm talking about, Java 3 I'm teaching. Okay? And there's a wider range of the other topic for Java 4. Okay? Is that okay? So here we are actually A course is here, B course is here. Is that okay? We have two semesters. So this semester from June to somewhere around before September, we will be on A. Okay, September to Christmas time, it will be B course, Java 2. Is that okay?
Okay.
And after that, we may go for Java 3 and then do competition. And then in February 2021, we will go back to AP Computer Science review. Okay, that's the plan we have.
Okay.
Okay, so that actually is our plan. Okay, so we use Java as our pilot language. So we actually use it to explore the world. Is that okay? It's our pilot language.
Okay.
It's our pilot language. And then AP Computer Science will test you Java 8. But right now, this a little bit 1 year ago, right now already Java 14, okay?
Java 14.
Yeah. The newest version is Java 14, okay? And the one we are tested on is up to Java 8. Is that okay?
Why is Java 8 so popular? I've heard it been used in so many things.
Yeah, it's actually been used for maybe 10 years or something. It's quite a long time. The reason why Java 10, 9, 10, 11 doesn't become popular because it adds on a lot of new features and people not really using it. You know what I'm saying? So AP test still up to Java 8, okay? And we have IDE, we have Eclipse, Intelligent IDE, we have BlueJ. So BlueJ is used by 49% of the teachers, so we continue to use this one. If you want to install this one, I can show you how to do it. This one no good, okay? This one too complicated. This one too complicated, okay? This one complicated, okay?
I actually have IntelliJ IDEA and Eclipse.
Yeah. Much more complicated.
I think, it's much more complicated. I only got it because I wanted to like mod stuff.
Yeah.
Mod stuff in like games to add my own stuff using code.
Yeah.
But here's the thing, I can't really do anything right now because the game in particular is going to update and I have to wait for that update to go so I can actually do anything.
Yeah. And actually the version changed a lot. So
yeah,
it's hard for you to track for the newest version always. And because if you don't have a super fast computer, you actually end up using a very bulky software and slow down your programming, okay? So unless that you know how to do it, otherwise we don't suggest that, okay? Now this one is the first program, Hello World, okay? So this one actually I don't teach it, but now we are going to the next topic actually is the compilation flow, okay? This one actually today I will need you to actually try to exercise it, okay? We actually used to just do here, compile and run, right? Okay, and run. That's our way of doing programming. So here we do differently, okay? Here this compilation flow, I will have you to exercise at least once, okay? So now actually we are going to go for the DOS prompt computing. So let me show you, okay? So here, suppose that I'm going to here the BlueJ, okay? Under BlueJ I have chapter 1. Under this chapter 1, let me actually open by my Notepad++. So I open my Notepad++, okay. So over here, actually, I close everything. Okay, I can close everything. And then I save this file as, okay. So I go back to the directory, go to this AP Computer Science 21, J, okay, chapter 1. Here, let's do this one. Change to Java file, okay, Java file. So let's try this one called test.java, okay. So here I have a program called test.java, and language I tune as Java language, okay. So here I would have public class, okay, test, okay. And here I would just put public static void main. So I just try to actually print out test program. Is that okay? Is that okay here?
Okay.
So here I save. Okay, let me actually copy to you. Okay. So we got this file, okay? Now what I'm going to do actually over here is, let me close it, okay? Close this one. So over here I do Window R, okay? Window R bring up this runner, okay? Window is actually under your keyboard. Here we have the third key, erase the key with this. 4 square, right? That's actually called window. And click with R, you bring up this runner. Put CMD of the command, okay? You bring up this command, okay, command line. So you click OK, you bring up the command line, okay, something like this. So we do CD, but we want to change to this directory. So left click, right click, copy, come back to here, paste, dir, okay. So I have the test.java. So right here, I would do Java C. Java C is Java compiler, okay. So whenever you are in J and you actually here hit compile, that will run this Java C. So you Java C and then test.java, hit return. You compile, and you finish, okay? After you finish, you say Java and then test. You run and you'll get a test program. Is that okay?
Okay.
So this is a traditional way of using the text editor without IDE to run a Java program. Is that okay?
Okay.
So now actually, let me see. Let me see. Okay. How about Nathan? Let's give you the first try. Can you try this one? So this one show you the whole process of doing compilation using DOS. Okay. So everybody remember that. Try to do it. Okay. Now I pick some student to show everybody how to do it. Okay. Vanessa, are you okay?
Yeah, so I go to
Can you share your screen?
oh yeah, sorry.
So you need to have a program. You need to bring up your file folders. Yeah. So choose a directory that you usually store your programs. C drive maybe.
Yeah.
You kind of, you have Python users or somewhere. Where did you stop? You have Nathan. I think it's in Nathan. Okay, let's try this Java. Is that okay?
Yeah.
So this may be the Java. This may be the Java So let's try this one. Let's try create a new one.
Oh yeah, I need to move my Python here.
So let's do this one, CSA. Is that okay?
Mm-hmm.
So here, let's try actually one thing called project. Is that okay? So here we do chapter 1. Okay, now under chapter 1, can you create a text file called test.java? Yeah.
Okay.
Text document, right?
Yeah, text document. Fine. Just call it test. T-E-S-T. Yeah. Double click on it, open it. Okay, write a program. Write a very simple program. Whatever you like. Simple program. Whatever you
like. Just hello world.
Whatever.
Just the line, like print.
Yeah, whatever. Just a program. That can be wrong.
Okay.
Wait, I'm using a Mac. Would that change anything?
Mute what?
I'm using Mac OS.
Should be
You're
fine.
using Windows.
Should be fine. Hey, you a class, okay? You write a program, you need to have a class, right? Are you still writing Java?
Yeah.
And is the print line that's a Java?
Wait. No, oops.
And why are you deleting the print line? If you want to print something, it should be a system. It should be system.out.print, right?
Mm-hmm.
And you design a class. I just showed you a moment ago. Okay, you need to be focused, okay? Actually, I just showed you a moment ago. I just told you to write any Java program that can work, right?
Yeah.
Okay, this one I finished. So this one, actually, let me actually open it again, okay? So now I save as, if you are using this IDE, you can save as, here change to all files. Change to all files. And here you say test.java, okay? Click save. Okay, there's a test.java, okay? So now we have this test.java and we have this one here. Let's look at the view file extension. So you already have the file extension as Java, okay? So that's okay. Now, actually, we are going to, we have this file called test.java, okay? So we do Windows R, okay? And you type CMD here, okay? CD, you left click on this one, right click copy, okay? Go back to here, copy, change to there, dir. Okay, and we can do type.
Different on mine. It's different on mine.
Yeah, it can be different from yours. Okay, so here we have test.java and we do Java C. Okay, test.java.
I think I can do that.
So Java C is not quite recognized because you did not install the Java. Okay, you did not install the system Java. So the thing is that you may need to actually install a Java. Okay. So I suggest that you install a version called Java 10, JDK. Okay, older one, newer one doesn't help you. So let's actually try Java 10. Okay, so Java 10, Java Archive, Java Standard SE version, standard version. Okay, so here you have Java Standard standalone. There is a Java 14, the latest Java SE version. Okay, let's do this one, Java 14. whatever you want to have this 64-bit installer. Is that okay?
Yeah.
So this one is different from what we do using BlueJ. Can you download this one? This one, yeah. Okay, it take a while. Okay.
So we want 14?
Yeah. That's
Okay.
the newest one. But use a SE standard edition, okay? Standard edition.
Yeah. It's done.
Yeah. Okay, it's done. Can you run it?
What website is this on?
You can just do Java 10 JDK. You'll find it. Click next.
Where?
Click next. Click.
Do I get the installer or the compressed archive?
You get the installer. You are using Mac OS. You should use Mac OS installer.
Okay, thanks.
Is that okay? Okay, what happened?
Click next steps access tutorial. So I'll just close.
Close. Okay, good enough. Okay, good enough. Don't move. Okay, don't move. So now you got this one, right?
It's asking me to sign in.
Yeah, you need to sign in. Yes. So local disk, you go to your programs, okay, and here you have Java. Okay, here you have Java 14.01. This one is okay. Here you have bin binary program. So go down. Here you have Java C everything, right? So this one you click, left click, and right click copy. Okay, right click copy and go to here. You do right click setting. Okay, and over here you do advanced system. So view advanced system setting. Okay, you bring up this environment variable. Can you click this environment variable, please? Click environment variable.
Wait, here?
Click environment variable. Yeah. Go down to here. You have your path. Okay.
Mm-hmm.
Wait. Lower side, you have your path.
There's path here.
Don't use that one.
I'll scroll a little bit slower. Found it here.
So found this one. Edit. Okay.
Edit.
So here actually you have we create a new one. Can you click new? So pass the path over here. So let's see your path over here. Can you actually grab this path?
From behind?
Yeah, from behind, yes.
Oh wait, it won't let me yet. So
Yeah,
I'll just click cancel for now.
Click cancel.
I'll copy this if I can.
Yeah, you should do it, okay? I cannot do it for you. I cannot remote copy the path for you.
And then new. There. Is that it?
Yeah, click OK.
Okay.
Yeah, click OK.
Okay. And then is this done
and
too?
then click OK. Yeah, okay, good. Good enough, that's quick, okay? So here we have this one, chapter 1. Okay, let's try another one. So this break window, I'm going to give up, okay? This one do not have the newest path, so I close that one. So go back to my C drive, go back to Nathan, go back to CSP, go back to Java, go back to, I'm not Java, I should go to APCSA. So actually I should move this guy to outside, okay? It's actually over here, UJ, chapter 1. We have test, right? So over here, let's do window R. click CMD, okay, CD, go this one, left click, and then here I do right click copy, okay, go to here, pass, oh, I'm sorry, I actually need to put a space over there, okay, to the end, hit return, dir, okay, and then now I do actually Java C, okay, and then test.java. Yeah, and I do Java. This time, because I installed the new Java, it worked.
Yeah.
Oh, okay, it actually... Let me actually do this. Okay, this one is wrong. So your Java is the wrong version. Your Java is wrong version. So somehow you have older version of J. You set up different paths for the Java actually. So it doesn't recognize this version.
I just copied it from the one that you.
Yeah, but this actually is common because the Java 14 is too new. That's why I try to install Java 10. Is that okay?
Yeah, so should I try to install it again?
Yeah, install Java 10 if you can find the Java 10. Okay.
Yeah, I'll try that.
Probably too old, too new. Okay. Yeah. There is a Java 10. You probably need to do archive. Okay. Okay. Here actually.
Oh yeah, archive.
Yeah, archive. Do similar thing. Okay.
So Windows.
Windows, yes. So it doesn't support an older program. Okay.
What is this?
You need to apply for an account for it.
So should I do that now?
Yeah, later, please. Okay. This
Okay.
just show you how to download a new standalone, not Bluetooth version of the. The whole thing just teach you how to do a standalone installation. Okay. I know you may not be able to remember everything, so if you need to have know how to install it, please come to my course. Okay, here I have give you this course before. It's free. Okay, it's ecohacker.com. You come to here. Okay, and then you log in. Let me see. Okay. This one always had this problem. No, I don't want to log in from here. Let me try again. So here, let me grab this one. Okay. So here I give you this one more time. Here we actually have this one, software install course. Okay.
Okay, I finally installed Java 14. It took a while.
It take a while, yes. And it depends on how fast your computer is. So here it has the installation of the JDK video. Okay.
I now have multiple versions of Java. That's nice.
Yeah, I have 3 versions.
In this lecture, I'm going to show you
so
how to install
up to here, there's a
class.
course that will give you how to install this kind of the installer. Okay. So today I don't continue on this installation, but I'll give you this course. Okay. I'll give you this course, and there is a Java installation guide. Okay. Actually, this one has all kind of installation guide on this one. Okay. So that will teach you how to install a standalone Java, not the one come with BlueJ. So BlueJ picks some version for you. If you don't like that version, you can actually install different version. Okay. Any question up to here? So you probably need to try to install 14 different versions, okay? I'll give you a try, and if you do have problem, I can guide you later, okay? So this Java actually is a Java virtual machine based compiler. So you do Java C. Java C actually is when you do compile, it will compile for you. You will create something called bytecode. Okay? Bytecode is actually a temporary code. Okay, so it's actually 0101 some binary code, and the bytecode is stored in class. So you have test.java, it will compile to test.class. And this test.class can be run on Windows, can be run on Mac OS, can be run on Linux. Okay, so it actually is called platform independent. Okay, it's called platform independent. So you can run that program in different platforms. So Java has the advantage of being platform independent. Okay. Same thing here. Actually, we have the Python is also platform independent. You can also create Python pre-compiled code called Python C. Okay, that will also be platform independent. C++ language is not platform dependent because every machine they need to compile to a executable code. Okay, Java doesn't go to executable code. Java just compile to a class file, and you actually can make the class file portable to be run on different computer. Okay, so today I show you how to store actually run on the independent Java. Okay, and you should try. And if you see some problem, you can let me know. Okay. So we actually have Java virtual machine, and you load your program on. Okay, so every time actually when we run some program like this one, right? We run it, and it actually the Java virtual machine is running, right? And then the time keep ticking, right? Keep ticking. So here, if I actually reset it, I don't want to run. It actually reset Java virtual machine. So what that reset Java virtual really means? It means that this whatever time computer time program loaded to Java virtual machine, right? So Java virtual machine run this program. It actually computer time class being loaded. Okay, so we originally had computer time Java. That program being compiled to a byte file. Okay, bytecode file, and then that one loaded to Java virtual machine. So here it keep running, right? And if I want to have it to stop, I say reset my Java virtual machine, and then the program will start because all variable, all function are terminated. All function here will be terminated. Is that okay? All function here will be terminated. So that will terminate. So that's why here we have Java virtual machine. Okay? Okay, that's actually Java virtual machine. And the next one is Java language. Okay? Any question?
No.
Oh, no question.
No question? Okay. So I'll continue, okay? Because it's not too hard, so I will not give you a break, okay? I'll just try continue. So let me see. So Java machine, Java language. Okay, Java language, I don't repeat it because you know it already, okay? So here actually, it is an object-oriented programming language, okay? So you have encapsulation, abstraction, polymorphism, inheritance, class, and object, okay? And you have the event-driven programming. So Java also support the graphic user interface, okay? And this one is called Java JDK. Java JDK including Java C, Java Doc, jar, Java database, Java WebStar, Java applet, okay, Java FX, Java String, Java 2D, Java AWT. So the whole thing is called Java JDK, and Java running environment, including the web starters, okay, and Java SE API. API is your library. Is that okay? So here's three terms: Java API, Java runtime environment, and Java JDK. it really means the same package of different part, okay? And Java can now actually can also be run on Android, okay? So Android is now one of the major platforms that actually run Java right now, okay? This one is the Java virtual machine, okay? So we talk about a memory model. We load a program into our heap memory for the object, right? Pool for measure area for the static variable, okay? And we also have stack. So these are something we will talk about it later. Interpretation level, okay? Electronic, you have 0 and 1, okay? 0 and 1, actually, if you look at the waveform, the voltage low is 0, high is 1, okay? Something like that, okay? So basically, that's what computer is running, okay? So electronic-wise, we are having a high voltage to low voltage, okay? So right here, give you some sort of transistor. So the transistor symbol on the left side, electronic transfer curve on the right side. So if your input is low voltage, okay, say you are closing to 0 volt, you're closing to 0 volt, your voltage is right here. Your output here will be stopped. Here you'll be charging, so it actually will charge it to high voltage 5 volt. Okay? And your input 0 will become output 1. Okay? Is that okay?
Okay.
And then if you have a high voltage 5 volt, this one close, this one discharge the charge. So it becomes 0 volt. So your high voltage, the output is low. Your high voltage one output is low. So this one, we call it a inverter. Your A come in, you will get A bar. Is that okay?
Okay.
This thing, we call it an inverter. So logic is done by doing this. So all the computer design based on this logic, okay, based on similar logic. Okay, based on similar logic. So that's what we talk about the semiconductors, okay? If you hear Samsung or TSMC, they do competition on how many micron design. It actually is the design of this single transistor, okay? It is used to do computing. Then based on those electronics, we have the binary number system 010101, right? This type of thing is our binary number, and our machine all run on this number. And this number, in fact, as I said, on the transistor level is high voltage or low voltage. Is that okay? Is that okay?
Okay.
But logically, we think about it's 1 or 0. Low voltage-wise, it can be 1.8 volt versus 0 volt or 2.5 volt versus 0 volt, depending on your voltage system, okay? Then we have A12 bionic processor. So the processor, it has tons of different processing units in it, okay? Recent addition to this processor is this one, the neural processing unit, okay? So neural network being added to here, and so A12 can start to process your bionic features, such as your iris or your face recognition, okay? It's using TSMC 7 micron technology, okay? 6.9 billion transistors. Very, very huge design, okay? Okay, so machine language means that you are operating on 0101, okay? That's the high voltage or low voltage. So whenever we actually really want to run our program, you need to translate your high-level language from the Java format or Python format or C++ format down to the machine language level, okay? But this like machine language level actually is not readable, not easy to read, okay? So our software has an interface with the hardware. So hardware actually is a high voltage, low voltage, right? Something like that. We have instruction, you take in 0101, whatever. Okay, so this side is a machine. So the interface between your machine to your software is called instruction set architecture. So AMD, Intel, they are sharing the X86 instruction set architecture. Is that okay? So say I have a AMD instruction set architecture, right, 64-bit architecture, and I may have AMD running at 5 gigahertz. I may have an Intel processor running at 4.3 gigahertz. Two are compatible. One higher speed, the other one slower. Slower means clock wider. Okay? Is that okay?
Okay.
But as long as your 0101 is actually same sequence, two can run the same program. Is that okay?
Okay.
So this instruction set architecture is an interface between your software and hardware. You take the machine code, I convert it to waveform. Waveform may be of different clock, but it's okay. You can run it, I can run it. Your poor CPU 1 gigahertz can run it. My 2 gigahertz can also run it. Is that okay? So instruction set is some sort of a language that actually make two different machines of different speed, different memory size to run the same program. Is that okay?
Okay.
So that's the interface between your software and hardware. Lin, are you okay?
Yeah.
Yeah? How about Xiao? Are you okay? I will make sure you guys are okay.
Yeah.
Okay, so those are machine, actually instruction set, right? So 0101 actually not easy for people to understand, right? So when we design the instruction, it's not something like that, okay? It's still 0101, but we actually have something called instruction format. So what you see right here is instruction format. So there's an opcode. So opcode 5-bit, right? 5-bit, it may have one add, right? Maybe it's subtract, maybe it's a jump, okay, whatever, opcode. So maybe 00010, 5-bit, this means add, right? 00110, that may be subtract. Is that okay? So that option is the operation is called opcode. Is that okay? Operation code. Okay.
Okay.
And then that's the first 3-bit. Okay, there's 5-bit for it. Okay. Then we may have register number, rewrite. Actually, it's called memory model. Okay, memory mode. Okay, and here word or byte data. Okay, so there are some description on the instruction. So basically, usually an instruction can be add, register 1 to register 2 to register 3. Okay, so if we write a program, say integer a equals 3, integer b equals 4, and then integer c equals a plus b. Okay, it may means that you actually move a address data to maybe register 1, right? Then move B address data to register 2, okay? And then add register 1 with register 2 to register 3, okay? Then move your register 3 back to C variable. Is that okay?
Okay.
So then you translate this one to 101011 whatever instruction and run it. Is that okay? So
Okay.
right hand side we call it assembly code. Left hand side is machine code. Machine code is what you see right here. Is that okay? And
Okay.
machine code is actually 0101 format, right? 0101 format. And the real machine, the real signal running actually is such a waveform. And the waveform may be adjusted by the computer speed. You know what I'm saying? It may be 1 gigahertz, I may be 1.2 gigahertz. Two running the same program, 0101 sequence never change, but the speed can be different, performance can be different. Is that okay?
Okay.
And the two waveform is compatible because we have a same instruction set architecture, okay? And machine code is the same, both 0101 is the same, okay? So we translate those kind of add F3, R1, R2, R3 to machine code. This portion is called this mnemonic. This mnemonic is actually called assembly code. So assembly code is some sort of human readable code, mapping one-to-one to the machine code. Is that okay? So you really see a assembly code like this in your program, okay? And it's a little bit better, but still not really 100% human readable, okay? Still need to have some training before you can read it. Is that okay?
Okay.
So we have the X86 Assembly Language, okay? And it looks like this. When you do debugging in assembly, it's like this. Left-hand side, you have assembly code. Right-hand side, you have current CPU register condition. Lower button, you have the code. Okay, so there's an assembler, emulator, and debugger helping to do assembly compilation. And we work on the CPU's data path. So here show you how register been operating. Okay. So here it really is actually let's pick actually, let's do add, let's do integer a equals 3, b equals 4, and then c equal a plus b case, okay? So basically you load your data to here, through here, go into your register, okay? So actually you do loading your register, your variable a to register 1, okay? And then you load your B in here, so lower 4 to here, so 3 and 4 can load it. After that, actually, you see a add operation. So you get the instruction, come here, equal add, okay? I know it's adding, so I add the register 1, 3 over here, 4 over here, 2 do sum together, so keep an instruction to sum. And then these 2 will calculate as 7. And this 7 will be actually being right back to here a register 3, and then register 3 being read out and then sent to the memory for variable C. Is that okay?
Okay.
Okay, so this one here, this CPU is somewhat like your abacus. So for you to do calculation, is that okay? And then we need to have a program to control it. So you move the data around to perform computation, okay? So then we have this 86 instruction set. Then, okay, the assembly is still not really readable. So we actually invent something more like English. It's called high-level language, such as Java language, okay? So high-level language need to be compiled directly to machine code, or can be compiled hardware to assembly code. So here we have the bytecode. It's also some sort of middle code, okay? It's close to the machine, but not 100% with the same with the machine. Okay, these are the top language of the peak recently, okay? So Java knowledge. Next one is Java duck, okay? So double slash is a comment out the rest of the line, okay? So slash star star slash, that actually is comment out a certain block, right? Star slash slash star 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 slash, that is useful command. It is not counted, but it's useful. Okay, let's look at this one. So here, let me actually create something called GCT, okay? So here I put my name, and I put my version. I can put 0607 2020. Okay, here we have this one called GCD. Okay, so let's do this one. I have a public static, okay, integer GCD. Okay, I get to number m and the integer n. I'm going to calculate the GCD. I get these two numbers. So if my n equals 0, then I will return m. M will be my GCD. Otherwise, I will return actually the GCD of n and the m modular by n. Okay. So this one is the so-called recursive Euclid algorithm for finding GCD. Okay. So here, let's do this one. Here we have public static void main. Okay, this one will find GCD. So let's try something. Okay. (32 and 48). Okay. Let's try a few things. (48) and the 32. Okay. And then I have 65 and 97. 65 and 97. 97 is a prime number, so you will get 1. 43, 42 and 32. 48 and 32, you get 16. Okay. So this one works just like this. You have 48, 32, right? So let's assume this one is m, this one is n for the time being. Okay. So 48 divided by 32 will be 1, remainder 16, right? So this one is actually n divided by n. This one is n modular by n. Okay. So because n is not 0, so I'm going to continue. But here I put my n32 over here. My m actually is the remainder, so be 16. So next time I come here, I run 2, and then I get 16, 32, 0 here. So here, and then this one is my new m modular by 2. So this is the new m. This one is new n. Okay. Is okay? This one's a new n divided by n. Okay. So after that, actually I switch again. So this one's the n. That will be my new m, green m. This one my green n. Green n is 0. Then green m is my answer. Is that okay? Is that okay?
Okay.
So this is called Euclid algorithm to find GCD. Euclid algorithm to find GCD. Let me see. Xiao, can you prove it?
Which parts should I prove?
So if I have actually m and n, right? How can I prove that GCD can be found by this Euclid algorithm? So let's assume that we have m equals aq plus r. I'm sorry, m equals af, right? Actually, n equals bf. When a prime with b, right? Then f a prime with b, the GCD is 1. Then f will be my GCD. Is that okay?
Okay.
Yeah, is that okay?
Yeah.
So now actually I have m divided by n, right? N divided by N, actually, it would be A divided by B. F cancel out, right? Right? And the remainder actually, if I actually have M divided by N, so M will be N times some sort of Q plus R, right? Right? So M is actually AF. So I would say R is actually also CF. R is also multiple of the CF. So you find MN's GCD is also the same as finding N and R's GCD. Is that okay? Yeah? Is that okay?
Yeah.
Yeah? You try to find M and N's GCD actually is also the same as finding N and R's GCD. And then you can do actually continue. You will prove that Euclid algorithm will actually find the GCD. Is that okay?
Okay.
Yeah. So basically you have M and N, and then you have N and M 10 modular by N. The GCD of this guy will be the GCD of this guy, right?
Yeah.
Okay. Only until that you have certain one N actually divided by certain number, and it actually is just AQ. Okay, it's full divide, and that number will be your GCD. Is that okay? That number will be F. Is that okay?
Okay.
Full divide. So a certain stage that actually you have N exactly equal M modular by N's times a factor. That one will be your GCD at a certain point. Is that okay? So that's how Euclid algorithm will work. Is that okay? Okay. The key point is we try to figure out this, okay? So here we have a double star here, and we can do here, okay, GCD algorithm. These are actually useless command, but we can also do this one, useful command. So here GCD function, parameter, we have parameter of the M and N, okay? Okay, so we can write something like this. I can also write something like this, okay? Okay, the double star one actually is useful code, so it's in green, blue color. So here I have source code, do documentation, and I'll switch to this page. And here you see the version is this one, name is my name, okay? And then here actually I have GCD, GCD, I click to GCD. You have parameter, you see, and the return value written here. Is that okay? So here, if I go back to my source code, it will be my source code. It will be like this. I can change to my documentation page. Is that okay?
Okay.
So this one actually, if you come to here and you search, let me try different thing, okay? This one probably not. So there's a document page. See here? So online, this scanner also have similar document. Is that okay?
Okay.
So basically, if I go back to my computer here, I have a DOC, right? And this DOC, I actually check the index. It is the page I see in my project. Is that okay? So basically, this DOC, I can pretty much copy the whole DOC to anywhere else or attach to a website. Is that okay? Is that okay?
Okay.
So this one is not only project not only can generate your code, but also your documentation page. An important thing is this author version. For a function, it will be parameter and return value. Is that okay?
Okay.
So this portion is Java doc, okay? Any question for here?
No.
So this AP level, I told you, I give you more things than the pre-AP, okay? Pre-AP, actually, we don't go this deep. And there are a lot of detailed things you need to learn here, okay? Okay, so then you have brace, that's for Cobra. Angle brackets, that for index, okay? Parentheses for a logic or a function, okay? Double quote for string boundary. Now we know it, okay? So the tool we are using called Java doc that will scan and process the command. Scan and process the command. So let's try this one, okay? Let's try this one here. I have this, right? I put this in, right? Let me see. Let me go back, okay? Oh, it didn't. It's not doesn't show up. Let me try. Okay, let me try. So here it has the double quote. So need to wrap it in pre. Okay. It need to be wrapped in pre. This allow you to include formatted fragments. Okay. Let's try pre-tag. Okay. This doesn't take effect. Okay, I'll check the version. Maybe this version not supported by project. Let me try here. Okay, try to see the index page by Google Chrome. Okay. No, it doesn't show up. I'll try. Okay, I'll try to see how to make it work in here. Okay. So basically, it's also possible that you actually put some HTML in there, can contain, but keep it simple, keep it like this, okay? So probably it doesn't take this color stuff, okay? Let me actually do this one. Let me just try this one. Let me just try this one, okay? It still doesn't show, okay? I'll check it, okay? Oh, I'm sorry, here I should have an EN. No, we still don't have. Okay, I'll check, okay? I'll check. It actually should be okay to put it over there. Okay, I'll check. Let me see. So there's some HTML, you can put it there, okay. Okay, then AP subset. AP computer science test will be following the AP subset. So not everything will be tested, but for the time being, you don't need to worry about AP subset. Your knowledge is way beyond AP subset, so no problem, okay? Only when we are doing exam, I told you which part is AP subset, which is not. Coding habit, okay, coding habit first, number one, class name. Class name usually using upper case, okay? So upper means the first letter need to be capital. Upper case, okay? C, okay? So hello, W high, uppercase. Is that okay?
Okay.
Other than that, actually, variable name, function name, always lowercase, okay? You try to align like this. This is my habit to put this like this, okay? You put the open one here, fine. I don't care, okay? So there are two styles you can follow. You can follow the way I did, put this open one here, closing one here. Open one, closing one, that's one habit. If you don't do that, you put curly brace over here, that is also fine, okay? So this style is also okay, as long as you align it well, okay, that actually is fine. But for me, I like this one because you don't have the extra line here. Okay? For me, I actually like that style. But either way, it's okay. This one is also okay. So this one is a Java script language, but actually is also applicable to Java. So some people suggest that you should leave some space over here, okay? And then here, empty line. If you finish some section, you put some empty line in logical blocks, okay? And don't put a line too long. You actually want to bend it down to the next line, okay? And some people suggest that when you call some function, inside is another function, put some space into there. I probably not actually following this one, okay? This one actually, I did not follow it every time, okay? And every functional level, you actually align two later, is that okay? Each block level align about 2 letters. That's a habit, okay? This not must have, but it actually is a convention. So package name always lowercase, okay? Class name called uppercase, means every leading letter in a word would be in uppercase, okay? And variable, we use a lower case. Okay, lower case means the leading words, leading letter is lowercase. Others leading letter are uppercase, okay? That's called lower case, okay? And class method is interface method same. Function name, variable name, constant name, variable name, same, lower case, okay?
Okay.
So left-hand side is not following the convention, right? Right-hand side is actually following the convention. The left-hand side, class name not preferred, okay? Variable name not preferred, okay? Constant, we usually use all capital, okay? So SIGE, all capital is welcome, okay? So that's a comparison, okay? We are done with this one. Any questions so far for this chapter 1?
Yeah.
Any question?
No question.
No question here. Actually, remember, go to this master course 22, okay? And right here we have, I'll put a link to to get a textbook over here, okay? And you need to do this one. You need to do chapter 1 quiz, okay? also Tuesday, chapter 1 quiz, and the project I talk about, the computer time. Is that okay?
Okay.
Two things for this week homework. Any question?
No.
And this course, I try to always give you project-based homework. So I will no longer give you those kind of coding back type function programming homework. It would be usually designing a class or multiple class. Is that okay?
Okay.
Any question?
No.
How about other student, Lynn or Shell? Any question? Hello, any question?
No.
No? How about Nathan? Are you okay?
Yeah, so yeah, I think I'm good.
For the installation of the independent Java, please try, okay? And let me know if you have question. I should have some time, maybe Tuesday or Wednesday. I usually have time. Is that okay? So you struggle a little bit for the installation. If still doesn't work, let me know, okay? Is that okay?
Yeah.
Then so far, I don't have the coding. But we will continue the coding bed on Friday night. Okay, we'll continue that. And other than that, we'll be project based. Is that okay? Okay. So enjoy your computer time. Okay. Bye now.
Okay. Goodbye. Thank.
Bye bye.